At 0530 local time, a Russian Bayan M-class corvette anchored in the Sea of Azov was in the final stages of preparing its 8-caliber cruise missiles for a strike on Ukrainian infrastructure. The crew of the 949-ton vessel believed they were operating in a secure maritime zone, completely unaware that they had been tracked for the past 45 minutes by a wolf pack of Ukrainian long-range strike drones. In exactly 180 seconds, a routine dawn patrol would transform into a masterclass in asymmetric naval warfare. The lead drone, a customized Rubak kamikaze unit, accelerated to 400 kilometers per hour as it crossed the coastline, instantly triggering the acoustic sensors of a Russian coastal defense checkpoint. The quiet morning air erupted with the sound of 23mm anti-aircraft fire, sending streams of tracers arcing into the dawn sky. Each high-explosive incendiary shell carried enough kinetic energy to turn the composite airframe of the drone into scattered debris. But the Russian gunners faced a physics problem they could not solve. They were firing at the sound of the engine, but at 400 kilometers per hour, the drone was already 300 meters ahead of its own acoustic signature. The gunner walked his rounds toward the distinctive whine of the modified gasoline engine, but the lead Rubak banked hard left, pushing its engine to maximum revolutions and screaming past the kill zone before the heavy barrel could traverse to track it. The initial survival of the lead drone, however, created an immediate tactical crisis for the rest of the squadron. The gunfire had alerted every Russian air defense position within a 10-kilometer radius, and messages were already spreading through encrypted telegram channels faster than official military radio networks could process them. The element of surprise, the drone operator's most valuable currency, was gone. On the operator's screens inside a bunker 300 kilometers away, video feeds suddenly filled with the static interference of high-voltage power lines that had been invisible against the dark terrain until the final second. The drone pulled up sharply, its belly scraping just 2 meters above 110,000 volts of live electricity. For 3 agonizing seconds, every instrument in the ground control station went haywire. The magnetic field from the power lines sent the digital compass spinning wildly while the video feed flickered into gray noise. The operator was flying blind, relying entirely on muscle memory and the drone's last known vector. When the video link re-established, a massive radio tower loomed out of the darkness directly in the flight path with milliseconds to spare. The operator banked hard left, missing the steel guy wires by mere inches. Behind the lead Rubak, 2 more drones followed 30 seconds apart, using the chaotic wake of the first to slip through the perimeter unnoticed. These were the Spear variants, specifically designed to blind the ship's radar defenses before the main heavy hitters arrived. While the Rubaks cleared the path, 4 Bober loitering munitions took the northern route, trading speed for payload. These drones carried heavier warheads designed to crack a ship's hull, acting as the hammer that would strike after the Spears removed the shield. The telegram warnings had traveled faster than the drones. As they approached the second defensive ring, a Repellent 1 electronic warfare system surged to life, flooding the control frequencies with 400 watts of broadband electromagnetic noise. The lead Bober's screen went black as the signal link was severed by the wall of interference, but the Ukrainians had anticipated this exact scenario. The moment the link dropped, the drone's onboard computer switched to autonomous terminal guidance, navigating solely by internal accelerometers and optical landmark recognition. The machine flew blind through the electromagnetic storm. 3 minutes later, as it exited the jamming bubble, the video feed snapped back online. The Bober was exactly on course, having drifted less than 12 meters over a 5-kilometer distance. But the relief was short-lived. Ahead, a BTR-82 armored personnel carrier blocked the highway, its 30mm automatic cannon already firing in predetermined interdiction patterns designed to create a wall of shrapnel. The operator of the lead Bober immediately dove the aircraft down into an industrial zone, skimming rooftops to break the line of sight. However, the industrial complex was not empty. Hearing the distinct lawnmower sound of the drone motors, Russian infantry poured out of the buildings like an anthill that had been kicked over. The drone held an altitude of exactly 10 meters. At this specific height, the curvature of the Earth creates a natural radar shadow that serves as a cloak of invisibility. A hilltop radar system that can detect targets at 50 kilometers when they are flying at altitude can only see 12 kilometers when the target is skimming the ground. Physics became their shield against the long-range sensors, but it offered no protection against small arms fire. The drones threaded invisible corridors of safety, while dozens of soldiers fired assault rifles at the fleeting sounds and glimpses of the airframes. But statistics do not lie. Even with a hit probability of 0.01% per bullet, the concentrated fire from a coordinated squad eventually connected. The third Rubac spiraled into a concrete parking lot, its warhead detonating on impact and sending a shockwave through the complex. There were now 2 Bobers and 2 Rubacs remaining. They could not afford to lose a single additional airframe if they wanted to sink the corvette. As the lead Rubac crested the final ridge before the coastline, the operator's screen filled with a terrifying silhouette that should not have been there. The mission briefing had been catastrophically wrong. The coastal defense was not a vintage Soviet system, but a modern Panzer S-1 battery. In 4 seconds, the operator would have to make a decision that would either save the mission or destroy every remaining drone. The Panzer launch vehicle fired 6 missiles simultaneously, but these were not ordinary surface-to-air missiles. These were the new Panzer SM anti-drone interceptors developed specifically after commercial quadcopters had humiliated Russian air defenses in previous years. Each missile weighed just 12 kilograms, but carried 200 tungsten spheres in a fragmentation warhead designed to create a donut-shaped kill zone specifically optimized for small UAVs. Upon detonation, these spheres would expand outward at 1,800 meters per second, creating a lethal cloud 10 meters in diameter that would shred the fragile composite wings of the drones. As the Panzer operator fired, he utilized ladder engagement tactics, launching missiles at staggered altitudes of 50 meters, 30 meters, and 10 meters, effectively creating a 3-dimensional box of death that the drone would have to fly through. The Rubac's operator, however, had studied Panzer engagement envelopes extensively and knew the missiles had a critical vulnerability, a 1.2-second arming delay after launch. This safety feature was designed to prevent the warhead from detonating too close to the launcher and killing its own crew. At 432 kilometers per hour, the drone covered 144 meters in those 1.2 seconds. The moment the operator saw the missiles flare, he pushed the control stick forward, diving the drone straight towards the Panzer vehicle in a suicidal game of chicken. The interceptor missiles streaked overhead, their proximity fuses still in safety mode, unable to detonate even as the drone passed within meters of their flight path. By the time the missiles armed, the Rubac was already below them, using the launcher's own safety protocols as a shield. The operator leveled out at 5 meters and lined up on the Podlet K-1 radar vehicle, the critical system providing targeting data to every Russian launcher within 200 kilometers. The Panzer's twin 30mm cannons opened fire, each barrel cycling at 5,000 rounds per minute, attempting to create a wall of lead in front of the incoming threat. The Russian gunner tried to employ boxing tactics, spraying rectangular zones of fire where the drone was predicted to be, but the fire control solution faced a mathematical lag that no software could fix. The system needed 1.5 seconds to calculate the trajectory, 0.5 seconds for the heavy servo motors to aim the turret, and another 1.5 seconds for the rounds to travel the 2 kilometers to the target. This created a total lag of 3.5 seconds. The drone operator simply changed course every 2 seconds, ensuring the Russian computer was always solving an outdated geometry problem. The Rubac punched through the curtain of fire and slammed directly into the radar antenna. The shaped charge detonated, creating the Monroe effect. This phenomenon occurs when a shaped charge's explosion crushes a copper cone into a hypersonic jet, not melting it, but deforming it under such extreme pressure that the solid metal behaves like a liquid, punching through armor like a needle through paper at 7,000 meters per second. The jet perforated the antenna array, destroyed the processing units, and exited through the back wall, finally dispersing into a spray of molten copper. With the primary fire control radar destroyed, the second Rubac targeted the nearby P-18 spoon rest early warning radar. The Panzer crew switched to their thermal imaging backup, but the dawn hour had created a phenomenon known as temperature inversion, where a layer of cool air is trapped under a layer of warm air. This atmospheric condition causes thermal shimmer and generates false heat signatures as the air layers mix. The drone's electric motors generated minimal heat, registering maybe 10 degrees Celsius above ambient temperature against the warming morning sea that still retained heat from the previous day. On the thermal display, the drone appeared as a faint cold spot, then disappeared entirely when flying over cooler patches of land. The thermal imager processing algorithm, designed to track jet engines burning at 600 degrees Celsius, could not maintain a lock on such a small temperature differential. The Pantsir gunner fired in desperation mode using a predetermined spiral pattern, starting at the drone's last known position and expanding outward. This water hose technique might work against a helicopter that cannot change direction instantly, but the drone pivoted 90 degrees in half a second. 5,000 rounds were expended and 0 hits were achieved. The Rubak struck the P-18 dead center, eliminating 200 kilometers of radar coverage in an instant. With both primary radars destroyed, the Corvette located 4 kilometers offshore had completely lost its early warning network. Without the podlet and the P-18 providing initial detection and tracking, the ship's own onboard radar was limited to the horizon line, meaning it could only see 40 kilometers out, giving the crew less than 2 minutes of warning against low-flying threats. The defensive shield protecting the Corvette had just vanished. The ship that was preparing to launch missiles at Ukrainian cities was now blind and alone. The Corvette's radar finally detected the incoming drones at 4 kilometers, but they appeared as ghost contacts that flickered in and out of existence with each wave. The Russian ship faced an impossible problem, distinguishing drones flying at 3 meters altitude from waves that were 2 meters high. Both created radar returns of similar intensity. The Doppler shift effect, which normally separates moving targets from stationary objects, failed because the drones were flying at variable speeds between 80 and 120 knots. The computer's clutter rejection algorithm, designed to filter out sea spray, started filtering out the real threats. Every third sweep of the radar, the drones disappeared entirely from the screen as the processor decided they must be false returns. That did not stop the Russian crew from trying to use their last line of defense. The AK-630M2 duet system spun up with a mechanical whine, and 10,000 rounds per minute erupted from the twin 30mm rotary cannons. The fire control computer tried to calculate intercept paths using Kalman filtering algorithms. Kalman filtering attempts to predict where a moving target will be next by mathematically combining its past positions with current sensor data. Much like trying to guess where a zigzagging car is headed by averaging what you see with what physics says is possible. But the drone operators were throwing these calculations off by making random input adjustments every 2 seconds. The Duet system had been designed to engage P-270 Mosket missiles, 3,000-kilogram weapons flying predictable linear trajectories, not 150-kilogram drones maneuvering randomly. It was like using a sledgehammer to hit a hummingbird. The computer needed 3.5 seconds to generate a valid firing solution. But since the drones changed course every 2 seconds, the math never aligned. Undeterred by missing all their shots, the Corvette deployed its PK-10 decoy system, launching clouds of chaff. These aluminum strips cut to exactly half the wavelength of the targeting radar created a radar return larger than the drone itself. Within seconds, hundreds of false targets bloomed on every radar screen within 50 kilometers. Against radar-guided missiles, this would create impenetrable confusion. But against drones guided by human operators watching through high-definition cameras, it created nothing but pretty sparkles in the morning sun. The operators ignored the light show and maintained visual lock on the ship. The Corvette's TK-25E electronic countermeasure suite activated next, pumping out 200 watts across the spectrum from 20 megahertz to 40 gigahertz. Against normal radio-controlled drones, this would sever the control link instantly, but the Ukrainian drones used frequency-hopping spread spectrum technology, jumping between 128 channels per second in a pseudo-random pattern known only to the transmitter and receiver. The jamming affected individual hops, causing occasional frame drops and pixelation in the video feed, but it never blocked enough sequential channels to break the link. The video feed degraded from 1080p to 480p, annoying but still usable. Sensing what was coming next, the Corvette captain ordered evasive S-turns at maximum speed, but physics does not negotiate. The 949-ton vessel needed 15 seconds to change heading 30 degrees. The drone needed 50 milliseconds. The lead Bober drone operator recognized the ship's movement pattern and timed his approach for the steady period between turns. At 500 meters, the operator switched to manual control, the radar mast filling his screen with 6 meters of critical electronics. The duet cannons could not depress below -5 degrees. And at 200 meters range and 3 meters altitude, trigonometry put the drone under their engagement arc. Sailors with PKM. Machine guns fired from the deck, but they faced an impossible physiological problem. The drone crossed their field of view in 0.8 seconds. Human eyes need 0.2 seconds to focus on a moving target, another 0.3 seconds to track it, and 0.2 seconds to aim. By the time they pulled the trigger, the drone had moved 100 meters. They were literally firing at afterimages burned into their retinas. The first Bober slammed face first into the mast. Instantly, every radar, communication suite, and data link on the ship went down. No longer able to fire their missiles, they were now a sitting duck. The second Bober dove toward the corvette's port side at a 30-degree angle, its operator aiming for the junction between frames 44 and 52, where the missile magazine sat behind 15 millimeters of steel plating. At 100 meters, the operator made his final adjustment, accounting for the ship's 8-knot drift and 3-degree list from the hard turn. The shaped charge needed to hit at exactly 90 degrees for maximum penetration. Too shallow and it would deflect. Too steep and it would waste energy. The operator had practiced this moment 500 times in simulation, but reality included variables no simulation captured: hands shaking from adrenaline, sea spray on the camera lens, and the knowledge that missing meant friends would continue suffering under caliber bombardment. The Bober struck exactly at the missile magazine's forward bulkhead. Its shaped charge created a jet of molten metal moving at 7,000 meters per second. The 15mm steel plate offered the same resistance as tissue paper. The jet punched through, spraying molten copper across stored ammunition and missile components. The explosion ruptured 3 separate systems simultaneously. Hydraulic fluid at 3,000 pounds per square inch sprayed across electrical panels, creating instant arc fires. Missile coolant lines burst, releasing toxic hydrazine derivatives. And most critically, the warhead safety interlocks disconnected, leaving 8 caliber missiles armed but useless. The corvette did not sink, but it crawled into port 12 hours later with its superstructure blackened and its hull opened in several places. Recovery would take 18 months minimum. Ukrainian operators sitting in bunkers 300 kilometers away had knocked out a warship costing $500 million using parts bought off the internet. The initial blast was only the catalyst for a much darker chain reaction deep within the ship's bowels. As the damage control teams rushed to Compartment 4, they were not just fighting fire. They were fighting chemistry. The corvette's superstructure, constructed from a specialized aluminum-magnesium alloy to reduce displacement, ignited at temperatures exceeding 1,200 degrees Celsius, creating a Class D metal fire that standard water hoses could not extinguish. In fact, when the desperate crew turned their nozzles on the burning bulkheads, the intense heat caused the water molecules to undergo thermal dissociation, splitting into hydrogen and oxygen upon contact with the superheated metal. This effectively fed the fire with explosive rocket fuel rather than suppressing it, turning the corridor into a blast furnace. Ventilation shafts, originally designed to circulate cool air to the sensitive electronics, now acted as high-speed chimneys, pumping toxic hydrazine vapors and combustion byproducts directly into the command information center. The captain watched his tactical screens flicker and die one by one, not because of the drone strikes, but because the silver-zinc batteries in the backup power supply had reached their thermal runaway threshold. In the end, it was not the shaped charge that took the ship out of the war for the next year. It was the inescapable laws of thermodynamics turning the vessel's own advanced materials against it.